Okay, so now we're talking about connective tissue, and specifically this time supporting connective tissue. So if you remember from the lab exercise, there's two main types. We're going to have bone and we're going to have cartilage, and then there are going to be three different subtypes of cartilage. Okay, so let's begin by going through our note packets and talking a little bit about some of the different types of cartilage, okay, and bone. So one thing you should know is that it has cells within the connective tissue. Anytime you see something that says chondra, that's going to equal cartilage, okay? So chondra equals cartilage. So we're going to see some similarities between cartilage and bone, but look for these root words. So osteo or ost, okay, or os, that's going to equal bone, okay? So a lot of these words may be similar. Just remember, if you're talking about cartilage, you're going to have this chondra, and bone is going to have these sorts of prefixes. So if we go back here, the main cells within the connective tissue for all cartilage is going to be chondrocytes, okay? Whereas with bone, the main cell within the tissue is going to be osteocytes. Now we're going to learn whenever we get to chapter 6 that there are other types of cells associated with these, but these are the main ones within the tissue. Most of the other types of cells associated with bone or cartilage are going to be found on the edges. Okay, so let's look at the fibers. So within hyaline cartilage, we're going to have mostly collagen. With elastic cartilage, we're going to have mostly elastic. And with fibrous cartilage, we're going to have, again, mostly collagen, but it's going to be arranged into thick bundles. So that gives it a lot of extra strength for this fibrous cartilage. Now the important molecule that's going to be in the matrix for all cartilages is going to be chondroitin sulfate, and this gives cartilage its kind of slick and slick qualities is this molecule in the extracellular matrix, and so you can write chondroitin sulfate down for all of these. Bone, the main fiber within the tissue, is also going to be collagen, but in bone we're also going to have calcium salts, and these are going to give bone unique properties that we'll talk about more, I think mostly in chapter 6. Okay. Now, as we talked about in the lab, the cells are found, this matrix, it makes it it's kind of a solid matrix. That's what allows these connective tissues to give such support and structure to the body. And so cells kind of have to have a hollowed out region within that matrix that they live in. So they live in a little hole. And again, that hole is called a lacuna. Okay? And so a lacuna is going to, all of the cells are going to be sitting within that hole for all types of cartilage, as well as all types of bones. So locations found in the body, okay, so elastic cartilage is two of the main locations. It's going to be the external ear and the epiglottis. Epiglottis helps, it's a little thing internal above your voice box, and it helps close off your windpipe when you swallow, so you don't swallow food under normal circumstances. Fibrous cartilage, we're going to find that in the knee joint. We're going to find that in a thing called the pubic symphysis. So that's where your two pubic bones come together, right in the pubic area. Okay, and we're going to find this in intervertebral discs. And so those are going to be the little pads that sit in between your vertebrae. Okay, bone, well, we're going to find that anywhere we find bone. Hyaline cartilage is the most common type of cartilage. We're going to find that between the ribs and the sternum. Okay, so ribs here, sternum is that breastbone up front. Any sort of movable joint, we're going to find hyaline cartilage between the bones, so movable joints. Trachea, if you feel your trachea, you might feel rings going down, and each of those rings is hyaline cartilage. And then the nasal septum in deep there, that is also going to be hyaline cartilage. Okay, so what are the functions of the tissue? So hyaline cartilage, it's going to be stiff, it's going to be flexible, it's going to be slick. Okay, elastic cartilage, it gives even greater flexibility because remember those elastic tissues, if you bend them, they spring back. Okay. Fibrocartilage is really meant to resist compression. If you think here's one vertebra, here's another vertebra, they're on top of each other, you're going jogging, so they would be hitting against each other without fibrocartilage. Fibrocartilage sits between them and allows them to basically not compress down on each other over time. Okay. Bone, it's going to be there to give your body structure. It can protect you from impact, so we think about our skull bones, they protect underlying tissues from some sort of mechanical impact. They're a lever for movement, so if I'm moving my finger, the muscles pull on the bones to move them, and that allows me to move. And then because of these calcium salts, it turns out that the bones are very important storage sites for calcium, and so those are some of the different functions that we find. Again, I'd encourage you to go through this, look for similarities and differences in these tissues. Now we do want to talk about two types of growth that we see particularly with cartilage, and we're going to talk about it here. We've got appositional growth, and that is going to be growth at the edges of the cartilage. And interstitial growth is going to be growth from the inside of the cartilage. Okay, and let's just look for a minute at some images that will help us understand this type of growth. Okay, so one thing you should know, this here in the light blue, this is showing cartilage. Right here is a chondrocyte sitting in a lacuna. I told you there would be other cells at the edges of the cartilage, and one of those types of cells we see here, it's called a chondroblast. So here's a chondroblast, here's a chondroblast. These are the immature cartilage cells on the edge of cartilage. You should also notice there's this perichondrium right here at the edge. That's connective tissue that surrounds that outside of every sorts of cartilage, and that's why we have fibroblasts there, because it is a connective tissue. The dark blue here is showing brand new cartilage matrix being made, so that chondroitin sulfate. And we notice here the amount of this dark blue, it's grown, such that this cell that was only partially surrounded by cartilage matrix is now fully surrounded. And so these two cells, once they're fully surrounded, they then kind of graduate and become chondrocytes. So this is a chondrocyte now, this is a chondrocyte now. And so you can see the cartilage initially started just this thick, and through appositional growth on the edges, we've now gotten thicker and even thicker. And so that's how cartilage will grow. Now, another thing to look at is interstitial growth. So this, we're looking at a chondrocyte sitting in its lacuna, and the light blue shows that it's completely surrounded by cartilage matrix, that chondroitin sulfate. Here we have the cell dividing, so it's splitting in half. So two new cells, and I kind of like to think of it, they think this house, it's not big enough for the both of us. This lacuna is not big enough for the both of us. What they do is each cell starts secreting chondroitin sulfate, that matrix, and that pushes them away from each other. Okay? But this is happening from the inside, so it's pushing from the inside to make it bigger. Whereas appositional growth is just adding more and more to the edges. Okay, so interstitial growth happens from the inside, and I think IN makes me think of inside, and that's how I remember it. Okay, so I believe that goes through the different types of cartilage. I just point out that it goes through the different types of growth. I point out that you do have these activities to help you learn this information step by step. I do want to point out a couple of things on bone. So bone, we have osteocytes is the cell. They live in lacuna. But they have these two other words called canaliculi and periosteum. And so periosteum, similar to perichondrium, remember chondra is going to be referring to our cartilage. Okay, we have periosteum, very similar. Okay, and that's again going to be a layer of this dense irregular connective tissue that is going to be on the outside of the bone. Okay, so let me come back here and find a picture of bone. Okay, so this is a picture of bone, and I just want to show you what these things, canaliculi, are. So if we look here at our bone picture, any dark thing that we see right there, that's going to be an osteocyte sitting in its little lacuna. This in the center is the only exception. It's bigger, you notice. It's not kind of, the cells are squished flat. This is actually quite round. And this is actually blood vessels coming through the bone. But all of these other things are osteocytes sitting in lacuna. And what you may notice is these little stringy black lines. And they're going to connect one osteocyte with another. So what these are is they're tiny little canals, tiny little tunnels. And these osteocytes, they're going to send a bit of their plasma membrane out through that little canal, and they kind of touch or tickle their neighbors next door. That allows these osteocytes to communicate with each other and to work together for the health of the bone. Okay, and so the little canal that the osteocytes communicate through is called a canaliculi. It sounds a little bit like, can I lick your eye? So, canaliculi. And if that helps you remember it, then use that.